All right. Hello, everyone. Good afternoon, and welcome to my talk about migrating to Java 9 modules using ModiTect. I hope you enjoyed the conference so far. I appreciate it very much that you show up here during your lunch break. That's really great effort. I work as a software engineer at Red Hat, and luckily I got accepted with some other talks at Devoxx this year. So the project I'm working on mostly these days is Debezium, a tool for change data capturing. I'm going to do a session about this tonight at 5:50, so you're very heartily invited to that. I worked as the spec lead for Bean Validation 2.0, so we did a new revision of the Bean Validation spec. There will be a quickie about that one tomorrow noon. And finally, I'm working on MapStruct, which is a code generator for bean-to-bean mappings. It's a side project of mine, and there will be another quickie also tomorrow noon. But now, enough with the advertisements. Let's talk a bit about ModiTect, and I also should mention it's a side project of mine. It's not an official Red Hat project. So what is it about? The idea is to provide you with some tooling which helps you with A, creating the module descriptors for the Java 9 module system, and B, with helping you with creating modular runtime images as they are introduced in Java 9. And so I cannot give you the full introduction to the Java 9 module system. I hope, or I assume if you are here, you know what it is about. But let's just take a quick look at this module descriptor. And what it does is it defines the module and some metadata. So it defines, for instance, all the required modules. And we already can think about maybe we could automate this to some degree because it kind of resembles the dependencies which we very likely have expressed, for instance, in our Maven POM or in our Cradle build file. So we might try and derive those requires clauses from the dependencies of our build tool. And then another part here is the exports clauses. So they describe the public API of our module. So what are the publicly available types? And right now you have to specify all the packages which are exposed one by one. You don't have any support for wildcards or something like that. So again, this might be something which we could do a bit better, perhaps. And speaking a bit about these modular runtime images, so I think they're one of the most interesting additions in Java 9. And what they let you do is you can create an image, let's say a directory, which contains your application, your dependencies, and the Java modules, the modules of the JDK which you are using. And this gives you a self-contained image of your application and its dependencies. And I will show you a bit how this can be done or created using ModiTect. And one important thing to keep in mind is for creating such a modular runtime image, you cannot use the automatic modules, which you may have heard about. So you only can use explicitly created modules. And at this point in time, of course, it's a problem. We don't have modules for many of our dependencies. So ModiTect will help you a bit with that. And with that, let me go to the Eclipse project I've created. So this is the first thing I'm going to show is based on Hibernate Validator. So this is the reference implementation for Bean Validation 2.0. And now I would like to create a module descriptor for Hibernate Validator. So I have this project in my IDE here. And the first thing I can do is I configure this Maven plugin. So there's a ModiTect Maven plugin. I get it from Maven Central, and I call this add module info goal here. And now the first option I have is I can just give the module descriptor inline in the POM here. So this is the same contents you would otherwise write in the module -info.java source file. Now you might wonder, okay, what's the advantage of doing this here in the POM instead of giving it in an actual source file? And the reason is, or the advantage is, this also works on Java SE8. So you can keep your build on Java SE8 and still produce a modular jar. And this might be interesting for you if you are a library author, let's say, and you would like to create a module, but for some reason you would like to keep your own build on Java SE8 for the time being. So this could be done. But still, it's quite verbose. So for instance, we have all those export clauses here. So let me remove this. I have all the exports here. I have all the requires clauses, which essentially kind of match the dependencies of Hibernate Validator. And I have those uses and provides clauses here, which deal with services which this jar uses. So let me remove this. And let me show you an alternative way to achieve the same. And here the idea is that ModiTect will create let's call it a candidate descriptor, and then this configuration is applied to it to refine and amend this generated descriptor. And I will run you through it, but first let me start the build, because this laptop isn't super fast, so I will just build it in the background. And now let me explain you a bit what's going on here. So first of all, I need a module name, so of course I need that. And then those requires clauses, they just are rules which amend the automatically discovered dependencies. So the tool will go there, it will analyze the classes of your classes, it will find the dependencies you use based on the dependencies given in your POM file, and then those rules will be applied in order to, for instance, add some of those modifiers. So in case of the jboss.logging.annotations dependency, I happen to know this is something which isn't needed at runtime. It's an optional feature. So I'm adding this static modifier here. Or in the case of the java.validation module, so that's the public bean validation API, this also should be exposed to the user of the Hibernate Validator module. So it must be a transitive dependency, transitive dependency. So I'm adding the transitive modifier here, and all the other dependencies which have been determined automatically, they should just be added as is. That's expressed using this asterisk operator. Then in terms of the exported packages, again, it's a set of rules which are processed from top to bottom, and all the packages in this module are processed against those rules, and as soon as one of the rules matches, no further rules will be processed. So this here means the validator internal util logging package, this should be a qualified export to the org jboss logging module, which we need for some technical reasons. Then all packages which have the internal in their name, they should not be exported. So I'm expressing this using the exclamation mark operator. I'm saying everything which is in internal, it should not be part of the public API, of course. And finally, all other packages, which match then the star asterisk operator, they should be part of the public API. And based on that, a module descriptor will be generated for me. We can take a look at it now. And there's this new describe module flag for the jar command. So I can take a look now at the generated or at the module, the build module and its descriptor. And well, it's no surprise, it resembles the one which I had been given before explicitly, right? But with much less configuration. So I'm just getting all the exported packages here. Remember, I just had to specify a bit of configuration for this. And I'm also getting the requires clauses and so on. And with a small amount of configuration. All right, so that's creating descriptors. Now, let me talk a bit about creating those modular runtime images. And for that, I have an example. I've prepared an example, and this is using Undertow, which is the web server in the JBoss application server, Wildfly. And I would like to create a modular runtime image which contains Undertow and which just produces a hello world. And for that, I'm having here this simple main class. It just launches the Undertow server, and it just returns an HTTP or a query parameter back to the caller. That's it. And let's see how we can create a modular image with that. And again, I'm using the ModiTect Maven plugin here. And what I'm doing now is I need to add descriptors for all the dependencies. So remember, at this point, neither Undertow nor any of its dependencies have the explicit module descriptor, but I would need them, or I need them for this to be used in a modular runtime image. So we have to add it. And I'm doing this using, again, this Maven plugin here. And now I specify all those dependencies which I would like to add. And I give some configuration for a module descriptor here. So let's say this logging module, it should have optional static dependencies to the actually logging backends, because we don't want to have all of them in there. Or let's go to the Undertow module. Here I just define a module name, and otherwise I'm fine. And then there's this other goal called create runtime image, and this is used to produce the actual image. And this one will add all those modules which we have been creating. It will create a launcher, which we will see in a bit, and then there are some options for compression, stripping, debugging symbols, and so on. So let me run this. And so what it does now is it takes all those dependencies which I had configured there, copies them to a staging directory, adds the module descriptors based on the configuration we have given in the POM file, and then it produces the modular runtime image from that. So it's using this compression flag, so that's why it's taking a bit longer. but it should be there. So first of all, let me run it. So there's a modular runtime image can have a launcher, which essentially is just a simple shell command or shell script or batch script. I can run that, and let me go here and let me just call it. So you see it's actually doing something, so it just returns hello Devoxx because I use Devoxx as the query parameter. So apparently Undertow is working, that's cool. Let me stop it. Let's take a look at the size of this. And so this has been created, the image has been created under target jlink image, and it's just 29 megabytes, so that's not so bad, I would say, for including Undertow, all its dependencies, and all the JDK modules we need. And let's take a look what's in the module. And for this, there is this list modules option there now. And I see all the images, all the modules which are contained in this image. And this is kind of what I would expect. So there's my com example, that's my own module. There's Undertow, some Java modules, and our dependencies. One thing strikes out if you look closely, and this is java.sql. So you might wonder, hey, why is there Java SQL? It's a web service or web server. Why do we have SQL in there? And the reason being is this. So I took a look at Undertow and its sources, and I figured, okay, there's a specific log appender which uses JDBC to emit log files. So there is, they have this Undertow logger interface here, and this has a dependency to SQL exception, and this explains why the java.sql module is pulled in here. But if I don't use this JDBC log appender, well, then I just don't need this module, right? So what I can do is, so I send a pull request to Undertow and to get rid of this or to make it truly optional, and I can change to that version now. So I have a locally patched version with this change here. And I can now amend the module descriptor for the Undertow module a bit. So I'm now saying, okay, please add the static modifier to the Java SQL dependence of this Undertow module. And now if I run it again, the resulting image should be a bit smaller. And I'm making this point just to explain a bit also how, well, with some small code changes, we actually can even improve the size of this stuff. So let's take a look now. And, oops, sorry. And now it's just 25 megabytes instead of 29, right? And so this is, I think, really a good thing for having in mind. It's a full-blown web server and all the Java modules in there. That's it in terms of a demo. So what is it about ModiTect? It's a tool which aids you with defining module descriptors and runtime images, as you have seen. And the idea is really not to fully generate a descriptor, because this does not make sense. We cannot know which should be your public API, but instead it just helps you with automating some of these steps, right? So we can analyze the dependencies, we can help you with those patterns for exports and make this a bit easier. And if you, for instance, add now a new public package, well, this will automatically, when you rebuild the stuff, it will add this to the generated descriptor, right? As otherwise, it might be quite easy for you to forget to add this new public package. Some things I would like to add. There could be support for cross-platform builds. So currently, such a runtime image, it will be specific to the platform which you have been using to build to create this module. There is some sort of cross-platform support in the jlink tool, but this could be made more easy for you to be used. And finally, there could be an idea for what could be called hollow runtime images, meaning we could create a runtime image which just contains your dependencies and the JDK modules, but not your actual application itself. The reason being this stuff changes much less frequently, so you would have a rather stable image which you don't have to rebuild very often, and then you just would add on top of this your explicit module with your application. This, for instance, might be very nice if you think about Docker containers and their layered file systems. And with that, I'm done. There are some resources, so it's all on GitHub. It's all open source. If you would like to contribute, I would be very happy. And there's 1 minute left for questions. Thank you. Any questions? If not, then I would say thank you for being here and enjoy the rest of the conference. Thank you.